Alright, so today we're solving equations, specifically the ones that have rational expressions. Let me just say a word about this. Every time you see this phrase here, rational expressions, what you could think about is something easier maybe. Just think about fractions. Often these words are almost interchangeable. Rational expressions means expressions that have fractions, and so rational numbers are numbers that can be expressed as a fraction with integers on top and non-zero integers on the bottom. So there's an intimate relationship between these two words, fractions and rationals. So the easier point of view on this is just we're doing equations that have fractions. Alright, let's get on with it. Here's the plan of attack. Every time you have an equation that has fractions, the plan of attack will be to kill the fractions, kill the denominators. And what I mean by that is find the least common multiple for the denominators, and once you find the least common multiple, you could multiply both sides by that, and nice things will happen when you do that. What are the nice things that will happen? All the denominators will be cleared and you'll have an equation that has no fractions. Alright, talk is cheap, let's do it. So here I have 1 over 9 plus x over 6 is equal to negative 5 over 12. I see that I have a 9, a 6, and a 12, and I'm going to guess that my least common multiple is 36. Okay? So I shall multiply both sides, everything, by 36. 36 on this side and 36 on that side. And I will justify it by the Cancellation Law of Multiplication, which says I can do that. Okay, having done that, this 36 gets distributed, so I have 36 times 1 over 9 plus 36 times x over 6, and that's 36 times negative 5 over 12. That would be the distributive law. Beautiful. Again, if we did this carefully, it will clean up extremely nicely. Watch how it cleans up. The 9 and the 6, well, you can cancel that and you get a 4 out of that. Here you can cancel that and you get a 6. Here you can cancel that and you get a 3. So that could turn into something I promised you, a very, very nice cleaned up version of the original equation. Here I have a 4 left. 4 times 1 is 4. 6 times x is 6x. 3 times negative 5 is negative 15. And so we have a very, very nice version of the original equation that has no more fractions. So this whole section is about rational equations, which means equations with fractions. The plan of attack is kill the fractions, kill the denominators. And now you have something easy. Here I can subtract 4 from both sides, and I probably get something like this. Cancellation law of addition and some minor axioms. And of course, the only thing left to do here is kill the coefficient, which would mean slap a 1 over 6 on both sides. And there you go. That's how we solve equations that have fractions. We kill the denominators by finding the least common multiple. In this case, the least common multiple is 36. Okay. I want to talk more about that right now. Sometimes you can just eyeball it and you can see that the least common multiple is 36. But sometimes it's not so easy. So I think you're going to do yourself a lot of good by learning a more professional way of doing this. And of course, we talked about this before. The more professional way is by prime factorizing the denominators. Let's have a look at the same problem done a different way. Instead of going with this, I prime factorize the denominator. So I see I have 1 over 3 times 3, that's a 9. I have an x over a 2 times 3, that's the 6. And I have a 2 times 2 times 3. This is all by times table. It's prime factorizing the bottoms. So I can just look at it and I can see what are the prime pieces that I have to kill. And what I'll do is I'll just kill all of them one at a time. Here, I'm going to pick something like red to kill. So I see I got to kill these two 3's. So I will multiply a 3 times a 3. That will kill them. But of course, just to be fair, I should distribute that on both sides to every single term. Count the terms. You've got 1, 2, 2 terms on the left, 1 term on the right. That's how many times you have to distribute whatever you multiply both sides by. Every single term gets a piece of it by the distributive law. Alright, that would get rid of my 3 problems, but I see I have a 2 here and I have 2 2's here. So the way to kill those would be to multiply everything by 2, 2. And so I'll multiply by 2 and 2 and 2 and 2. And so again, I justify this by cancellation law of multiplication, and the nice thing here is that, that's all I have to kill, 2's and 3's, so there's nothing else. This is my least common multiple. The least common multiple between 9 and 6 and 12 is equal to 2 times 2 times 3 times 3. Okay, which of course is 36 using the other way, but this is more powerful. Alright, the other nice thing about this is that it tells you exactly what's left over. See, here I cancel that 3 and cancel that 3 and cancel that 3, and it tells me exactly what's left over at 2 times a 2 times a 1. Here I cancel the 3, I cancel the 2, and there I have a 2 and a 3 left over. Here I cancel the 2 and the 2 and the 2, and I have a 3 times a 3 left over. Wait, that 3 goes away too. And so, as promised, this should clean up nicely. 2 times 2 times 1 is 4. 2 times 3 times x is 6x, and that's equal to 3 times negative 5, negative 15, and the rest of that is the same as before. So this idea of prime factorizing the bottom is powerful. It's the professional way to tackle these. Let's have another example here, maybe one with actual x's on the bottom. There we go. And we're going to try to do this the professional way. So the professional way would mean that I would look to prime factorize the denominators. I have a 3 and a 3 and an x. Here I have an x, I have a 2 and a 3, and here I have a 2 times a 2 times a 3, that's 12, times an x. So here I have all my prime pieces. I got to kill all the prime pieces on the denominators. For that, it's easy. I just use a different color. I'm going to go with green today. So I'll start off with killing the 3's. Oops, sorry. What? So I'll start off by killing the 3's. So here I go killing the 3's. I see I have the most amount of 3's is 2. I have this one has 2, this one has 1, this one has 1. So 2 3's would kill all of the 3's. So I have 3 times 3, 3 times 3. Cancellation law of multiplication allows me to multiply everything by 3 and distribute it to every term. Now I gotta kill the 2's. I see I have 2 2's there, so I go 2 and a 2, 2 and a 2, 2 and a 2. And I see I have an x there, so I should multiply everything by x, x, x. This way, everything on the denominator will be killed here. You'll see the x would cancel that x, the 3 would cancel that 3, the 3 would cancel that 3. I can see exactly what would be left over. 2 2's, 2 2's, a 3, an x, an x. And so what would be left over would be something like this. 2 times 2 times 1. Well, that's 4. And here I have a 3 times x times x. That would be 3x squared. And over here I have a 3 times that. That would be negative 5, negative 15. 3 times negative 5 is negative 15. That's my inspection. And now I've got a nice equation. I've got one with no more fractions. And so we can handle this the way we handle all our degree 2 equations. Subtract 4 from both sides gives me negative 19 by cancellation law of addition. I can subtract or slap a 1/3 on both sides so that I get rid of this 3. That would give me negative 19 over 3 by, you could just kill the coefficient. Now I have this square here, and now I think, well, I wish I had good ways of getting rid of that square. And you think, well, wait a minute, we do. We have the perfect medicine for that. It's called the square root property. Plus or minus the square root of negative 19 over 3. Square root property. And if you want to be fancy about it, we've handled this negative square roots before. All you do is pull out an I. 19 over 3 by definition of negative radicals. And so there you go, degree 2 solutions. I gotta come back and talk about this some more in just a second. So anyways, for now, this will be a good start to solve this equation. Rational equations with fractions. Alright, next, let's do one more here. We're going to use the same technique. We're going to prime factorize the bottom. So this is 9 times 2. That's a 3 times a 3 times a 2 times an x. Plus, that's a 3 over 2 times a 5 times an x is equal to 2x. That's a 3 times a 5. We're going to kill all the denominators. That's my plan of attack. Kill the denominators. So I'm going to multiply top and bottom by 3 times 3. I would get rid of those 3's. 3 times 3. Then I'd have no more 3's on the bottom. going to get rid of all the 5s. So I'll multiply everything by 5. Everything by 5. That will get rid of that 5 and that 5. What else do I need to get rid of? The 2's. I'll multiply by everything by 2. That will get rid of that 2, and there's no 2's there, so that's fine. And I'll multiply by x. That will get rid of that x. And if I do this, I will have no more denominators. All the denominators will be cancelled. So the x would cancel that x, the 3 and the 3 would cancel the 3 and the 3, 2 would cancel that 2. That's perfect. This 2 would cancel that 2, the 5 would cancel that 5, the x would cancel that x. The 3 would cancel that 3, the 5 would cancel that 5. And so at the end of the day we'd have a 5 and a 5, that would be 25, plus 3 times 3 times 3, that's 27. That's equal to 2x times 2 times x, that's 4x squared. So that 4x squared would be 52. So that would be equal to 52 over 4 is equal to x squared. So therefore x equals plus or minus the square root of 52 over 4 by square root property. That from here to here, that was by inspection. From here to here I added, that was the addition table. From here to here I killed the coefficient. Now right there's beautiful. We solved the degree 2 equation. Well, this degree 2 equation, the rational equation we solved as well. Alright, that gives you some practice. There's not that much new stuff here. This is just the same ideas that we've had before. Killing the denominators is only maybe slightly new because we've done it before with numbers. We just didn't do it when there was x's on the bottom. Luckily there's no difference in the technique. Works exactly the same way. Alright, next we should talk about the fundamental theorem of algebra. Super important.